Good day, boys and girls. Welcome to our televised mathematics lessons. I am Mrs. Cheryl Bradshaw. Today, our learning target is to multiply 2 and 3 and 4 digit numbers by 1 and 2 digit multipliers. We are going to be using hummingbird facts to help us do this job. As I read the facts on the screen, you can read along at home. Trinidad and Tobago is known as the land of the hummingbird. One of the birds on our coat of arms is a hummingbird. There are over 350 species of hummingbirds living in North, South, and Central America and the Caribbean. In Trinidad and Tobago, we can boast of having 18 species. One amazing fact is these brightly colored birds have wings that can beat between 12 to 80 times per second. See, numbers do not exist by themselves. They are always within a context. So here we have 350, which is a 3-digit number. Then we have 18, which is a 2-digit number, 12, and 80. Right away, we can see that 18 falls between 12 and 80. We are going to use these facts as we multiply. Our first problem is on the screen. As I read it, you can read it at home. If a hummingbird flutters its wings at 59 times per second, how many flutters will it do in 4 seconds? Here is your problem, and we are going to solve it. But we are going to use some problem-solving steps to solve it. You have 4 steps. Step 1, read and understand. Step 2, plan. Step 3, you do what you have planned. And step 4, check. Check to make sure that your plan works. And if it doesn't work, you go back to step 1. The first step in our problem-solving process is to read and understand our problem. So I'm going to read it again to you. It's written right here. You can read it also. If a hummingbird flutters its wings at 59 times per second, how many times will it flutter in 4 seconds? So the first thing we are going to find is, what do we know? And what do we know is written right here. The hummingbird flutters its wings at 59 times per second. Per second means 1 second, 59 flutters. The next thing we want to find out is, how many times will it flutter in 4 seconds? So we'll circle that one. This is what we want to find out. This is what we know. This is what we want to find out. 4 seconds. To help us to understand it, we'll draw a picture. And that picture will be in the form of a bar model. So we're going to draw a bar to represent the whole number of flutters. And that bar, we are going to divide it into 4 parts. 4 parts because it's 4 seconds. 1, 2, 3, 4. Now we don't know how much time it's going to take, or how much flutters it's going to take for those 4 seconds. So we'll put a question mark. That question mark tells us that we don't know. But we know that each second it's going to flutter 59 times. So we're going to write 59 in each part. So we are going to solve this problem using these base 10 blocks. Now your teachers would have used these base 10 blocks at your school. But just for those of you all who don't know what it looks like, I'm going to demonstrate. This base 10 block is a unit. It's 1. It represents 1. When we take 10 of these ones, we put them together and we form a 10, which is sometimes called a rod. We can take 10 of these rods and form 100 flat. We can use 10 of these hundreds to form 1,000 cube. On my table here, I have 59 made up of 5 tens and 9 ones. 5 tens and 9 ones, 5 tens and 9 ones, 5 10 and 9 ones. We have our 5 tens, which is 50, and that 50 is repeated 4 times. And then we have our 9 ones, and that 9 ones is repeated 4 times. We are going to count our 50s. We have 50 in this row, 50 in this row, that's 100. Another 50 is 150. And the last 50, the fourth 50, is 200. So 50 taken 4 times is equal to 200. Now we go to our 9 ones. And we have 9 ones taken 4 times, and that's 36. Now we have to put those two numbers together. 200 add 36 is equal to 236 times. We are going to use another method for solving this problem. It's a multiplicative method. It's called multiplying using an area model. Now, an area model is made up of squares and rectangles. But before we draw area model, we have to expand or distribute our numbers. We are going to look first at the number 59. We can expand the 59 as 50 plus 9. And then we put 50 plus 9. Remember, we have to multiply that by 4. So now we are going to draw our rectangles. This rectangle has a length of 50 and a breadth of 4, because we are multiplying 50 by 4. And just as we do in area, we multiply our length by our breadth. It's the same thing we are doing when we use this area model. The next rectangle we are going to draw is our rectangle for 9 by 4. So here is our 9, and here is our 4. So this is 9, and this is 4. 9 multiplied by 4. Within our rectangles, we can write our number sentence. 50 multiplied by 4. If you look across there, you're going to see it's 200. And the 9 multiplied by 4, we know is 36. These are what we call our partial products. It's not the full product. It's one part of the product and another part of the product. So we're going to find the sum of these two partial products, just as we did it down here. And it's right here. 200 add 36, which is 236. And this is how we call this again our area model. Our area model. During the break, you can try these two problems. Or if not, you can write them down to try them later. Second, even in eating, the hummingbird is very, very quick. We are going to use this fact to solve our next problem. Problem number 2. A hummingbird takes in 18 slurps of nectar each second. How many slurps will it take in 15 seconds? Here we have a problem that has a 2-digit number and another 2-digit number. We are going to use these two 2-digit numbers to solve our next problem. But before we do that, we are going to use our problem-solving steps to help us find out what we are supposed to do. Do you remember our problem-solving steps? Step 1, repeat it as I repeat it. Read and understand. Step 2, plan what you are going to do. Step 3, do what you have planned. And step 4, check to see if your plan worked. If it doesn't work, you go back to the beginning and read and understand again. Now we are going to solve problem number 2. We are going to use the same problem-solving steps. Step 1 is read and understand. So we're going to reread this problem. While I read it, at home you can read it yourself. A hummingbird takes 18 slurps of nectar each second. How many slurps will it take in 15 seconds? We next have to find out what we know. What do we know? We know that a hummingbird takes 18 slurps each second. We want to find out how many slurps it will take in 15 seconds. So we'll circle that. So we know 1 second (18 slurps). We want to find out for 15 seconds. We don't know that, so we're going to put a question mark there. Now we are going to draw a bar to show that we understand. This is our bar, and our bar would have 15 parts. And in each part, we are going to have 18 to represent the 18 slurps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We don't know how many in the whole, but we know in each of these parts we have 18. Now we can do like in the last problem, we could add all these 18s together. But we could also just write a multiplication number sentence. So a multiplication number sentence is going to be 18 taken 15 times. We notice in this number sentence, we have two two-digit numbers. The last number sentence we had a one-digit multiplier, while in this number sentence we have a two-digit multiplier. Now on the table in front of me, we have an area model made up using base 10 blocks. Here we have our flats, which is 10 multiplied by 10. We have 8 rods in another rectangle. So here is a square, here is a rectangle. Here is another rectangle, a 10 by 5. And here is another rectangle, a 8 by 5. Now I'm going to draw it on the board, and I'm going to write out our distributive number sentence. Now I remind you, using our distributive property, we can expand our numbers. So let's expand 18. 18 will be expanded as 10 plus 8, and 15 will be expanded as 10 plus 5. And we are going to multiply these two distributed numbers. Now, how are we going to multiply them? First, we are going to multiply our 10 by 10. And if we look on our table here, we have 10 by 10. So that's 10 multiplied by 10, and that is equal to 100. Over here we have the other one, which is 8 multiplied by 10. So we have just multiplied 18 by the 110 in the 15, which is 8 multiplied by 10. If we look at our table here, we can see we have 8 rods. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. 10 rods. That would be 80. Next, we are going to multiply our 10 by 5. So if we look here, we're going to see that we have 10 by 1, 2, 3, 4, 5, which is our next rectangle. And 10 multiplied by 5 is equal to 50. Finally, we are going to take our 8 and multiply by 5. So before, we took our 10 and we multiplied it by 10. That's it there. And then we took our 8 and multiplied it by 10. So it would have been this 18 that we multiplied by the 10 in 15. Now we are taking our 18 and we are multiplying our 18 by the 5. So we have taken our 10 and we have multiplied it by 5. The final one is to take our 8 and multiply it by 5. So if we look on the table here, we're going to see that we have 8 ones multiplied by 1, 2, 3, 4, 5. So we have 8 multiplied by 5. So this is 40. All of these are 4 partial products. That we're going to take those 4 partial products or 4 parts of our products and we are going to add them. Find the sum. So 10 by 10 is 100. So we're going to put 100. 8 by 10 is 80. So you're going to add 80. 10 by 5 is 50. So we are going to add the 50. 8 by 5 is 40. So we're going to add the 40. And that is equal to 270. So how many slurps will it take? 270 slurps. Now, just in case you do not have these at your school, and I know you may not have it at home, what could you have used instead of those base 10 blocks? You could have drawn a simple area model. Just as I showed you before, you distribute your numbers, which is 10 plus 8 multiply by 10 plus 5. And you draw your rectangles and your squares. This, we are multiplying our 18 first by 10. And next we are going to multiply our 18 by 5. So this is our first. We're drawing a 10 by 10. That's a square. So we have 10 by 10, 10 by 10. Then we have 8, which is a rectangle, by 10. Finally, we have 10 by 5. So this is your 10 here, by 5. And finally, we have your 8 multiplied by 5. 8, this line here will be 8 also, and this line here will be 5 also. So working for this rectangle here, you will have 10, 8, by 10. Here you are going to have 10 by 5 and 8 by 5. 10 by 10, as we worked before, is 100. 8 by 10 would be 80. 10 by 5 would be 50. And 8 by 5 will be 40. When we add it all up, there we have our 100. There we have our 80. There we have our 50. And there we have our 40. We add all our products and we have 270 slopes. And this is our area model. The last method I'm going to show you is what many of you all are doing in school. But I'm going to leave this up to show you and to match what you do in school with what we have done here. That method is called the algorithm. And you may find it familiar. So I'm going to write the number sentence just as you do in school. We have 18, and we are going to multiply that 18 by 15. These are our ones, and these are our tens. Just as we multiply our 8 ones by our 5 ones, we are going to do the same thing here. And we are going to say 8 multiplied by 5 is 40. This is our 40. This is ones, and these are tens. We're going to have to regroup. Our 0 ones come here, and our tens remain there. Then we are going to multiply our 10 by our 5 now. So 5 by the 10 is 50. But we say 5 ones are 5. And when I put my 5 here, it becomes 5 tens, or 50. When I add that 5 tens to these 4 tens that remain, it becomes how many tens? 9 tens. So I have 9 here. It makes it 90. We have just completed our ones, where we multiply our 18 by 5 ones. Now we are going to multiply our 18 by 110. If we look across here, we're going to see that when we multiplied our 18 by 110, we did 10 multiplied by 10, which is this 110 multiplied by this 110. And we also took our 8 ones and we multiplied it by 110. That's the same thing we are going to do. We're going to begin first with our 8 ones multiplied by our 110. Just as we saw, 8 multiplied by 110 was 80, which is 0 ones and 8 tens. So we are going to put down our 0 ones and our 8 tens. Now we are going to multiply our 110 by our 110, our 110 by our 110, right? Which is 10 by 10 is going to give you 100. 100. Which is 0 ones, 0 tens, and 100. So we can write it all the way in the bottom here, or we can just put it right on this side here. This will make it the 100. Normally in school you would say 1 multiplied by 1 is 1. But what this really means, that this 110 multiplied by this 110 is really 100. And since we had 80 before, it's now 180. If we combine these two numbers, we are partial products. We're going to get 180. Now we add these two products. We have 0, 9 and 8 is 17, 1 and 1 is 2. 270 slips. Now we are going to try these 2 examples during the break. If you don't want to do them now, you can write them down and do them later. Our third problem is a three-step problem. You are going to use some of the same methods that we used before to solve this problem. As I read the problem, you can read at home. One hummingbird's wings beat 25 times per second. Another hummingbird's wings beat 20 times per second. What is the difference in the number of beats in 2 minutes? You can also use the same problem solving steps that we used before to solve this problem, remembering that this problem has 3 steps. Multiplication is governed by certain rules and certain properties. And those rules remain the same and is true every time. One of the rules is called the commutative property, which means that it doesn't matter in which order you multiply numbers, the product is always the same. So you can multiply 2 multiplied by 3 and your product going to be 6, or you could put the factor 3 before the 2 and your product will always be 6. There is another rule. It's called the associative property. This associative property says that 2 or more factors can be grouped. And it doesn't matter what grouping you multiply first or second or third, the product is always the same. Like the example that we have here. I can multiply 2 by 3, get 6, and then multiply it by 4, and my product would be 24. Or I can multiply 3 by 4, which will be 12, and multiply that 12 by 2, and my product is still going to be 24. So it doesn't matter how I group my factors to multiply, the product is the same. And that stands true for all numbers. Here we have 2 more multiplicative properties. The identity property. And the identity property says that a number, when you multiply it by 1, the product is always that number. So 12 multiplied by 1 is 12. Finally, we have the zero property, which says that when you multiply factors, if one of the factor is 0, the product is always 0. So you can use these properties or rules to help you when you are solving multiplication problems. Here we have problem number 3. It's a 3-step problem. We are going to read it first because our problem solving step says read and understand, plan, then do, then check. So we are going to read. To understand, a hummingbird's wings beat 25 times per second. Another hummingbird's wings beat 20 times per second. What is the difference in the number of beats in 2 minutes? We are going to underline what we know. We know that a hummingbird, which is one hummingbird, beat 25 times per second. We also know that another hummingbird wings beat 20 times per second. But they want us to find the difference. So we're going to double underline the difference. Difference. What's the difference in the number of beats in 2 minutes? So 2 minutes is important. That's one of the things we have to find out. First of all, before we begin to solve this problem, we notice that we have 2 different units. Here we have second, and here we have minutes. So first we have to establish the relationship between seconds and minutes. We know that there are 60 seconds in 1 minute. So we have 60 seconds in 1 minute. So in 2 minutes, we will have how many seconds? We also know that one hummingbird, we call that hummingbird 1. H for hummingbird. His wings beat 25 times. And we know that hummingbird 2, his wings beat 20 times. So that's the information, that's what we know. So we're going to use what we know to find out what we don't know. So we are going to find out what is missing here, the amount of seconds in 2 minutes. We are going to draw a bar model to model it. This is our bar. This bar represents the number of seconds. We know that we have 2 minutes, but we also know that there are 60 seconds in each minute. So we can multiply 60 multiplied by 2 to find out how many seconds. 2 by 0 is 0, and 2 by 6 is 12, 120 seconds. So for each bird, their wings have to beat for a length of 120 seconds. From there now we can get our 2 number sentences. 1 second is 25 times for H1. For H2 we have 1 second at 20 times. So we're going to take that 120 multiply it by 25 for H1. Then we are going to take for H2, take that 120 and multiply it by 20. Now we have this modeled with our base 10 blocks on the table here. I'm going to show you all the partial products, and we're going to write the answers on the board, and we're going to sum those partial products. So I'm going to remove this to sum our partial products. I'm going to put H1 here for hummingbird 1 and H2 here for hummingbird 2. Let's start first with hummingbird 1. And our first partial product would be 100 represent this cube here, which is 100 by 10. And when I take 100 by 10, I get a cube like this, which represents 1,000. So I'm going to write this on the board. 100 multiplied by 10 equals 1,000. Here we have another 100 in line with this, multiplied by another 10, which makes it another 1,000, 2,000. So you have another 100 multiplied by 10, which is another 1,000, we have 2,000. Then we have 100. This whole row down there is going to be multiplied by this 100. 100 by 1, which is another 100. Same 100 multiplied by another 1, which is the second 100. 100 multiplied by another 1, and another 1, and another 1. So we have 1, 2, 3, 4, 5 hundredths. So we have 100 multiplied by 5, which is 500. And this row is 110 multiplied by 110, which is 100. And 110 multiplied by another 10, which is another 100. Okay? So it will be 110 multiplied by 10, which is 100, and another 10 multiplied by 10, which is another 100. Then we go down, we have a 10 multiplied by 1, which is one of these rods, and we have a 10 multiplied by 1, 2, 3, 4, 5. So we have 10 multiplied by 5, which is 50. We are in this row now, and we are repeating the same thing that we had before, which is a 10 by a 10, that makes 100, and a 10 by a 10, which makes another 100. 10 multiplied by 10 equals 100, and a 10 multiplied by 10, which is equal to another 100. Finally, we have a 10 multiplied by 1, 2, 3, 4, 5. That is this row at the bottom here. So it will be 10 multiplied by 5, which is, as you know, 50. Now what do? We take all these partial products and we add them all together. So now we are going to add our partial products using mental mathematics strategies. 1,000 and 1,000 is 2,000, and 500 is 2,500, 2,600, 2,700, 2,750, 2,850, 2,950, 3,000. So 120 multiplied by 25 is 3,000. And if we look at our base 10 blocks over here, we would recognize that we have 2,000, and we count 1, 2, 3, 4, 5, 6, 7, 8, 900, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 3,000. We now are going to use these blocks to find out the beats for Hummingbird 2. But as you saw in the last example, that we can just count the blocks to find out the total amount. So we are going to count. This is 1,000. This is another 1,000, which is 2,000. And below here we have 100, 200s, 300s, and 400s. So we have in total 2,400. So for Hummingbird 2, it would make 2,400 beats in 2 minutes. We are now going to find the difference between the number of beats for hummingbird 2 and the number of beats for hummingbird 1. So we are going to subtract 2,400 from 3,000. And using mental mathematics strategies, we know that 6 and 4 is 10. So 3,000 take away 2,400 is 600. Because 600 and 400 make another 1,000, which will move 2,000 to 3,000. Now we are going to solve the problem using the algorithm. So for hummingbird 1, we will multiply 120 multiplied by 25. 5 ones multiplied by 0 is 0. 5 twos are 10. 5 ones are 5. And the 1 is 6. So 120 multiplied by 5 is 600. Now we are going to multiply 120 by 20. And because we are multiplying by 2 tens, we have to add a 0 for the ones. So we have 2 tens multiplied by 0 is 0. 2 tens multiplied by 2 tens is 400. So the 4 goes under the 100. 2 tens multiplied by 100 is 2,000. So we have 2,400 when we multiply 120 by 20. Now we add our two products and we have 0, 0, 3,000. Now we are going to do our multiplication for hummingbird 2, which is 120 multiplied by 20. Any number that we multiply by a factor which is 0 is also 0. So 120 multiplied by 0 is 0. So we have 0 multiplied by 0 is 0, 0 multiplied by 2 is 0, 0 multiplied by 1 is 0. Now we are going to multiply 120 by 20. Because we are multiplying by 2 tens, we have to put 0 for the ones. So 2 tens multiplied by 0 is 0. 2 tens multiplied by 20, 2 tens here, which is 20. So 20 multiplied by 20 is 400. 2 tens, which is 20, multiplied by 100 is 2,000. Now we add our two products and we get 0, 0, 4, 2. 2,400. So now we have to find the difference between the 3,000 and the 2,400. 3,000 subtract 2,400, as we saw before, was 600. 600 beats.